Hey folks, we'll get started in just a minute. All right, let's get going. So welcome to Study Hall. So yeah, as usual, this is a place for you all to bring your questions. Feel free to put a question in under the thread in the comment that or in the message that I posted in Learn. And I'll be happy to take your questions on stream. Just leave a link to the problem, and I'll be able to go through it. All right, let me just adjust this. Cool. So I'm not seeing any questions at the moment. So I think we'll just go through the material for now. So last time we left off on tuples. This is just going through Tuple Basics. So tuples are kind of a subtly useful type. I talked a little bit about this last study hall. I think they're easy to underestimate because they're usually we describe them as like lists that are immutable. So they don't have the mutable features of lists. I talk a lot about mutability and immutability on stream, like when I lecture, but I think it's worth going over again just to really kind of drive this home regarding tuples. So let's look at lists first. Let's have a list, an empty list. Oops. And let's look at the directory. We'll say Python 3, dir. We'll look at the directory for a list, and this is going to show us all the methods for lists. Okay, so if you look through if you call dir on a list and get all the methods, obviously I'm just going to ignore the dunder methods for now. That those don't really pertain to this particular conversation. So you'll just look at all the regular named methods here. And let's just comment these out, right? So if we think about what each of these are going to do, if I print the value of my list, oops, and let's give it an initial value, hello, and then I list.append world onto, append that onto the list, and then let's print that off again. Okay, no big surprise here. This is going to change the value of the list. You can see we get hello printed, and then we get hello world printed. So I'm adding things into the list. So with a tuple, let's start it off with something like hello. Now, when we have a single element tuple, if you just surround something with parentheses, Python will think it's like that you're using like parentheses for like order of operations or something. So it'll treat that as like a priority to evaluate this group of whatever, this thing in the parentheses first. But in order to tell it that it's a tuple, we need to put a comma. So it's a little weird, but when you have a single element tuple, you just have to remember that you still have to have a comma at the end, and that's fine. You can actually do this with lists. It's fine to have a comma in there, but yeah, usually you don't if you don't need it. So that's our single element tuple. So let's do something like this. Okay, and actually I'm going to just comment out the list stuff for now. So let's just start off like this. Hello, hello, right? We see our initial tuple. So if I say tup plus equals a tuple with world in it. Cool. Okay. So I have this behavior that's very similar to this mutable method that lists have, right? So let's actually kind of try to isolate these. So these are, let's do, yeah. Let's cut this. So here we create our list and print it off. We're going to do our mutable modification, and then we'll print off list again, and we'll do the same thing for tuples. We will, here, let's put this here. We'll initialize the tuple, print it off. Here we go. Okay. So these two sets of behaviors are fairly similar. Right, we have a list starting value, and then a modified value, and then a tuple with a starting value and a modified value. So you might say, okay, well, you know, if you can, and without going through all of these examples of all of these, you can use, so what I'm doing here is I'm using concatenation. This is the same as saying tup plus this tuple, right? So I'm just using concatenation and reassigning the result of that concatenation into the same variable, which makes it kind of feel like a mutable operation, even though it's not, and I'll get to that in a second. And I can do, using concatenation, slicing, and indexing, I could do clear, I mean, that's just tup equals empty tuple, empty tuple like that. Copy is irrelevant because tuples are immutable. Again, we'll touch on that. Count is actually a method for tuples. It's not a mutable method, so it's kind of different. Extend is exactly like append. I just include more elements. Index, like count, is not a mutable method, so that actually does exist for tuples already. Insert, I would have to use slicing and concatenation and various indexing. Pop, remove, reverse. I can emulate all of these with concatenation, slicing, and indexing. The only one that I can't is sort, but there's a sorted function built in, so I kind of have that through other means. So I don't really lose any functionality, at least where you don't really lose any functionality with tuples, even though they're immutable. So let's actually look at these seem really similar, and let's actually look at why they're different and why that difference is important. So I think what I'm going to do here, we'll just copy, and I'll print the ID of each of these followed by the value. Let's try that. Okay. So if we look at these, so this list ID, and this will be different every time I run it. But it'll be consistent, across each run of it. And then if we do Okay. So if we look at these, let me restart my program there. Okay. If we look at these IDs, we start our list with a value in it. We print off the ID and the value. We append to that list. We print off the ID and the value. So notice with the list, the value changed, but the ID did not, which tells us that this is, even though the value is different at these 2 points, this is literally the same object. It's the same bytes in RAM that represent this list, right? So in your program's memory, it's looking in the same place for this list, right? So literally the same object. Whereas if we look at the tuple, the IDs are different. So this is a result of the concatenation, right? So when we concatenate an immutable type, like a string or a tuple, like this, it gives us back a different object that represents a tuple with both the current value of tup in it and the value of a tuple with world in it, right? So this is just this is an immutable operation, this tup plus world, right? This is a valid immutable operation. Let's just print that off, right? So you can see if let's isolate this a little bit. You can see if I just isolate this tuple code, right? So if I say print tup and then print tup plus world and then print tup again, right? That doing tup plus world didn't alter the value of tup, right? But what we can do is obviously just reassign this tup equals tup plus world. We can reassign tup like this. And that kind of gives us the behavior of an append. But it also literally gives us a different object in memory, right? So there are different reasons to do one over the other. There are certainly good times to use lists over tuples, and there are good times to use tuples over lists. One potential downside of tuples, if you're going to be like modifying them a lot, you have the potential for like duplicating information in your program's memory, right? On a small scale, or even on, I mean, small to the computer is probably larger than you think, but on a small, let's say a small or medium scale, that's often fine. It's often just fine to like have some memory duplication. You often won't have much or any detectable or real performance hit. There can be potentially a performance impact at a really large scale. But yeah, for a lot of operations, using an immutable type like this, even if there's the potential for some memory duplication, that's kind of okay. So let's look at one of the big advantages of this. Can I go over the okay, we got a question in here for me to go over the equivalent of append versus extend for tuples. Oh, versus extend. Yeah, I didn't go over extend because it's basically like an append. Here, let's make a new little section here, though. Okay. So let's look at list 1 equals, oops, hello world. and we'll say list2 equals, we'll just do this. List2 equals hello there. Hi there, planet. That's super creative, but whatever. So let's look at what extend does. We have list1 dot extend list2. Okay. So extend, the way I think about it is extend is like an append that allows you to append multiple things onto list1. It's like I've seen people try to do like dot append like A, B, C, or whatever. You can't do this with append. Append only takes one argument. Extend takes one argument too, but that argument is a list, and it's going to put all the elements in the list passed into the list it's called on, right? So if I print list1, of course, let's do it before and after, right? So before is hello world, after is hello world, hi there planet. Oh, oops, there we go. Hi there planet. So now it has both the elements. The reason this is different, extend is different than append, is if I append the entire list as a list, right? So notice the values are hello, then world, and then a list containing hi there planet, right? So that's the behavior of extend. So with a tuple, if we did something like this with a tuple, let's see, how do I do this? Okay. Oops. Let's see, how do I, nope. There we go. So let's call these tup. Okay, so we'll print tup. Tup1 is our target that we're going to modify, and we're going to modify it with tup2. So let's say, so I can't do dot extend. I have to say plus equals and then something with a tuple in it, right? So one way I could do this, if I wanted the append behavior, I could just throw it inside a single element tuple like this and just do that. And then I have hello world and then a tuple containing hi there planet, right? If I want to extend it, I can just plus equals like this. So extend and append are sort of like, with concatenation in tuples, are sort of not different. They're sort of trivially different. It's just a matter of like whether I'm putting it inside a nested tuple or not, right? So that's the deal. If you wanted to append multiple things, you can just concatenate against a tuple A, B, C, right? So it's kind of like a multiple append rather than a different thing that's like an extend with, as it is with a list. I actually, syntactically and paradigmatically, I really prefer the way that you deal with tuples with plus equals, concatenation, slicing, and indexing, because they're such consistent mechanics. If you understand them, you can just get them to do whatever you want. So I really like that behavior. Let me know if that's helpful to answering your question. Okay, cool. And I kind of got, probably should have taken that after I gave this example that I wanted to give here, because, let's see, let me try to oh yeah, okay. So I probably should have done that after I gave this example, so it wasn't quite as much of a break between ideas here, but and just to be clear, any follow-up questions to this concept are welcome as well. But let's see. So one thing I wanted to demonstrate is, we like, why would we choose immutable behavior? Why would we choose a tuple over a list, or a list over a tuple? Like, part of this is like, who cares if you have mutable methods on one, but you can just like reconstruct that behavior in an immutable type, then like, what's the point of the mutable type? And then if you think, well, if you're duplicating information in your memory, if that's a potential side effect of immutable behavior, what's the point of the immutable type, right? Like, you might look at either one and say, what's the point of the other? I mean, there is that difference of potential memory duplication, and I do stress the potential because it's a bit more complicated than like, oh yeah, there's definitely going to be a lot of memory duplication, or that would really slow your program down. The chances are pretty good that it wouldn't slow your program down. So let's look. This is probably the most important difference. Let's say I have my function, and we're going to print my function. Oh, and I jumped over somewhere. Oh, I'm in a different document. Just got a new computer, and shoot. I just realized I meant to increase the font size on this before we started. My bad. I usually do my own coding in a with a smaller font size like that, so I can just see more. I just forgot to change that. Let me readjust this really quick. It's good right about there. And then lock that down. Okay, cool. Hopefully that's a better text size. And I also remembered I meant to turn my microphone gain down a little bit, so you might have to turn your volume up. I'm hoping that will cut down on some of the background noise that people have told me about. Okay, cool. Hopefully that helps. All right. Let's see here. Where were we? Oh, right. I was giving an example of mutability. Okay, so my function will take an object, which object is going to be we'll start off as a list, and we'll say A, B, C, and we'll say my function def my function takes in some, we'll take an object, and just to distinguish between the two just so it's clear. My object, let's take an object and we'll say object dot append x. Okay, so then we'll return object. So you might look at this and think, okay, so my function just takes in an object, appends something to it, and then returns it. This is going to have a side effect. This returns the modified object, but it also literally just alters the object. Oh, here, let's do this. Okay. So ABCX. So notice that altered our original object. This might seem like, oh, you know, this is useful and powerful behavior. I guess that's a way of looking at it. This is canonically, and I'm just going to say universally regarded as an anti-pattern. You don't want to write code like this. If a function takes in an object, a mutable object, it should not cause a mutation to that object in the scope in which it was passed, right? So this is a global variable. It's a list. It's a global list. And I pass it to my function. And sorry. I pass it to my function, and the function modifies that variable on the global level, right? This variable is modified. And we can even kind of prove this a little further, right? We can say, what's the ID? ID, right? These are going to be the same ID, exactly the same ID. So it modifies the list that it takes in, returns it, and it returns the list, literally the same list that it modifies, right? So to get around this, obj equals obj dot copy, right? This is going to give us two different lists of two different IDs. One second here. I think I might have somebody DMing me in Slack. I'm not sure. Okay. Okay, sorry. Just had to check on that real quick. So yeah, let's see. Okay, so if I do this dot copy, then I'm going to return a different object. And if I delete the IDs here, name Q is not defined. Oops. I don't know where that Q came from. Okay, so in this case, right, our object is unmodified. We just get a different object returned like this. Let's see here real quick. Okay, so let's juxtapose this against a tuple. So my object is now a tuple, and instead of using append, we have to plus equals x. Tuples have no copy method, so it's irrelevant. But you can see it's sort of, we have the behavior of a copy anyways, right? So this is kind of the big central point of a tuple. not necessarily that, yeah, you can pass it to a function and it's already, it's not going to, the function's not going to mutate it. That's one definite advantage, but this is an example of, the effect of an advantage of immutability, right? In general, I would say I can count on, well, actually, absolutely, I can count on the value of this being consistent. The only time this is going to, quote, change is if I reassign my object this identifier name, if I reassign that identifier name to a different variable, right? So or to a different value. So that's the only time, I can trust that passing this around to different parts of my code, to other code bases, to other libraries, none of that's going to alter my data in a way that I didn't or can't anticipate. That isn't the case with lists. And sometimes that's good. Sometimes you want to hand off an object to an outside library so that it can be modified and have that back. But you want to be careful when you do that kind of thing, because too much of that, or using mutability sort of laissez-faire or without checks and balances or without caution, can make for some pretty unmaintainable code. So anyways, that's my mutability spiel. That's the mutability talk that I give over and over. Yeah, I know it's kind of a big topic though. That's why I like to, and apologies if you've seen my streams that you've seen me talk about that before, but it's a big enough topic that I think it's worth going over a few times. So, all right, so that's tuples in a nutshell, and how they're different, and sometimes better and sometimes not as good as lists. Cool. Let me see. Let's see. This is just going over some things that we went over for lists, like checks for membership. We have len. Just real quick, because I did the dir for lists. Let's do dir for tuples as well. Notice we just have two methods, count and index. It's the only two methods we have for tuples. Strings and lists also have these methods. They work exactly the same in all three of those data types. So yeah, if you're familiar with how to use these for lists and strings, that work exactly the same for tuples. Yeah, checks for membership. So everything you learned about slicing, concatenation, and indexing with lists also applies to tuples as well. And I'm just trying to see here. Tuple unpacking. This actually also works for lists, but we almost always see it with tuples because this is another example where immutability is kind of preferable. Because when you have an immutable object, you can predict its size. To be clear, though, when you have a mutable object, you can often bank on its size being something that you predict. You can often get away with that, and often it's fine, but you don't actually have a guarantee. Like, a mutable object's size can change. That's the point. You can add things or subtract things from it. You can alter things about it. That's the great thing about immutability. If something's immutable, you know what it is. You can guarantee what it is, right? So let's say we have my tup, and we don't know where this comes from, but we know it has three things in it. Oops. We know it has A, B, or let's do, oops, dang, sorry, X, Y, and Z. Okay. So my tup. So what I mean by we don't know where this comes from is maybe like a function returns this, or like we hit some API and it's, we get a tuple, we get an object back, a tuple with 3 things in it. I can say a comma b comma c equals my tup, and print c comma a comma b, whatever, I print them out of order, whatever I want to do with them. These are just variables like any other variable, zxy. So, excuse me. Yeah, this is a tuple deconstruction, right? The reason it's really handy to be able to predict the size here is, let's imagine this was a list, right? And hopefully we're going to consume this output as soon as possible, so we know what it is. But let's say this my tup, and this is no longer a tup. Sorry, my obj. This my object is from some part of our program, maybe like I said, function call, API, database. It's from somewhere. Let's pretend outside of the code that we wrote, right? We're bringing in this object from maybe a library or somewhere else, right? We know it's got 3 items in it, and somewhere along the way, before it gets to the part of our code where we alter it, maybe we wrote something somewhere before that we forgot about, or whatever, so we're going to append something to it, and just to prove that that worked, we'll print it off, my obj. Okay. So x, y, z, f. I don't know why I chose f, but whatever. So value error, too many values to unpack, right? And that's going to apply to this line. So when you write code like this, and there are times when writing code like this is really handy and really useful, you have to know how many variables you want to name in the thing. And if the size can't be guaranteed, then like what does that mean? So Python doesn't make some assumption about this. It just says I don't know what to do, and it throws an error, right? It says we expected 3, but there were too many values to unpack. Same thing if we did pop. Let's just pop a value. We'll get not enough values to unpack. Oops. So we'll get one of these 2 errors based on the size being different, which is essentially the same kind of thing. It's just there's either too many or not enough. So that's kind of the risk when you're unpacking a list, is you can't totally guarantee the size, unless you're certain that you can for whatever reason. Maybe your function call, just rather than saving to a variable out here, maybe you just do it right here, and you're like, I know it's going to go straight into there, and it's going to have 3 elements in it. But anyways, if we did have a list with 3 objects, oops, we could unpack it like that. But that's why we usually see this kind of behavior, like on 61. That's why we usually see it with tuples. We usually talk about unpacking tuples because of that ability to guarantee their size, which is because they're immutable. Okay. yeah, let's just jump into the challenges. And I think I said I wouldn't go through each of the mutable methods with lists, but I'm going to do the challenges, and I think I'll actually do this because it's actually a pretty worthwhile exercise. Okay, cool. Okay, so briefly describe a situation in which you would want to use a tuple over a list most of the time. IMO. I'm just going to do that. That's just me. I don't know. I really prefer immutable types though. Okay. Well, what's the result of running the following code block? Tup equals tup append. This is going to be an attribution error. It's going to say tuple has no attribute append. Oops, we got 2-space formatted code. That's not right. I'll have to go fix that. Let me take a note here. Challenge 3. There's 2-space indent. Okay, let's see. Returns the mode of the tuple. Tuple mode. Oh, okay. So complete the function tuple mode, which will calculate the mode of the past tuple. You can assume that the tuple will have only one mode, so we'll do the highest mode. Okay, so the mode is just the most frequent value, so I'm going to say mode equals, initially I'm going to start it at none, and then we'll say, let's do modal count. You know what? Actually, I'm going to do this, because I need to keep track of the count of the mode as well. Let me actually paste this in, work out of my editor. So I'm going to set this equal to a tuple itself, and it's going to have 2 elements actually. Which one will be a count, and the other will be the actual number, right? So let's say, and I could do this something like a dictionary and, you know, like label those count and mode or whatever, but I'm just going to do this for now. So we'll say for L and tup. I guess I can assume that these are numbers, so I'll just do num. So for num and tup, if tup.count num is greater than mode sub 0, which is where I'm storing my modal count, the prior highest number. So if tup.count num is greater than mode sub 0, we can mode equals, oh, I was going to do item assignment, but it's not a list. So we'll do mode with 0. So this is, so if this were a list, let me be real clear. If this were a list, I'd say mode sub 0, whoops, equals tup.count num. we'll say num count equals top dot count num, and we're just going to do this num. So I'm using it in two places. So this is what I'd do if it were a list, but in this case, if it's a tuple, I can't do that because item assignment is a mutable operation, and it is not supported for. Oops, it's not supported for tuples. Okay, so we'll do that plus mode, and we'll slice the mode. We'll start at 1 and go to the end, which is actually just mode 1, but we'll just do that. So this is how we would have to do item assignment. And of all the mutable operations that I think I know all the mutable operations for lists. Of all the mutable operations, this is like the ugliest to convert. This is like, this is kind of nice and simple with, that's what I meant to do, with lists, but it's kind of ugly with tuples. Okay, but you can do it. So this is one way. The easier way is to just do num here, though. So we don't actually need to do item assignment. We can just like reassign the tuple, something like this. We can just say mode equals num count and num, and that'll work fine. Oops. Okay. So that'll give us our mode, and then we need to return mode sub 1. Okay, I think that's it. Let's see if it works. Correct. Let's see what their solution was. Counts for tup in tup, or for I in tup counts dot append tup dot I count. Oh, so they're just making a list of counts. Max tup equals max of counts, and then it looks like we use max tup as the index to get the index of whatever that is in tup. It's an interesting way of doing it. I'm trying to think of a way to I'm just looking at this like, can I turn this into a one-liner? But I think that's not that important. Oh, oops, I meant to include that there. Okay. Okay. Let's go over those list methods. Talk about how to do these for tuples. So for lists, this is going to be, I'll just do this. For lists, this is going to be list.clear. That's going to just empty the list. So if we printed the value of the list, we'd just get an empty list. For this one, we can do we'll do top equals hello and top equals empty tuple, right? That's the same as clearing. Just reassign it to an empty thing, right? A copy isn't relevant for tuples, since every time we can perform transforms on tuples with concatenation, slicing, and indexing, but we get different objects back, which is kind of like a copy anyway. So you could think about them. I mean, it's an analogy. It's not an accurate one, but as an analogy, you could think about tuples as self-copying. It's an incorrect way of thinking about it, but it would be a working analogy. It would be a working paradigm, if that helps you understand it. Just know that that is not what's happening, but could help you understand it. Okay, count. Tuples just have the count method. So if I say tup equals 4, 5, 3, 4, 6, 5, 4, 7, 1. I forgot to mention this, but I don't need to put parentheses around this. I can just do this, and in this particular case, Python can, and in other cases as well, Python can infer that this is a tuple just by that, without me putting parentheses around it. So I can say print tup.count of 4. Let's do that. So there's 3 4s in there. How many 5s are in there? Looks like there's 2 5s. Cool. So that's just the count method. We just looked at extend. Index tuples have an index method. So if I want to do index of 5, if I want to print tup.index of 5, it's going to give me the index of 1, right? So it's going to give me the first index in which that value occurs, right? So let's do 11, right? So we get this error if we try to ask for an element that's not in the tuple. So you might, when you're using index, in general for a tuple or a list, you might try to remember to do if element in tup. Let's do lm equals 11. Then we can ask for its count. Something like that. Cool. Insert. Insert's a little tricky. Insert's going to be, insert is like a append. So if let's do list. List equals a list of 1, 2, 3, 4. And let's say I want to put something in between 2 and 3. I can say, let's print the list first. And we'll say list.insert. And gosh, I always forget if insert, I know what its arguments are, but I forget which order they go in. I think it's insert element index. I think it's element index. So let's say I want to put 100 between 2 and 3. So I want to put it at index 0, 1, 2. We'll try that. Nope, it's the other way around. 2. So index, then element. That's what it is. Okay. So how do we do this with a tuple? Let's say we can do idx equals 2, and we'll say tup equals tup sub, and we'll start at the beginning, and we'll go up to and not include idx plus a tuple containing the element that we want to add. And you don't have to break these into different variables. I'm just trying to do it just to kind of make things clear. So we want to add 100. Oops, and let's initialize that tup equal to, oh, I can just do that. 1, 2, 3, 4. Okay. So plus a tup with the element in it. Has to be a single element tup. We got to remember the comma. Can't forget the comma. and then we'll do tup sliced starting at index all the way to the end. I might need to do +1 here, but let's just see. Oops, print. Okay, so no, I don't need to do +1 there. So yeah, this is the equivalent of an insert with a tuple. We could like make a function like this. We could do def tuple insert takes a tup, an element. Oh wait, which way? Oh, let's do idx and element, and then we'll just return this. If you wanted to kind of wrap it up into something nice, and then you could do something like that. Just do this like I do any other function. So we'll say this takes in my tup. We'll call this my tup. And we'll do index 2. We want to put 100. Oh, name element. ELE. That's what I wanted to do. Cool. All right, so you can do stuff like this. And this is okay. You know, this is not going to alter. It's not going to alter my tup like the mutable method for a list would. Cool. All right. Okay, cool. So pop takes in an index and removes a value, right? Let's do something similar. Let's say def tuple pop will take in a tuple and we'll say it'll take in excuse me, IDX. And I'm going to set IDX equal to none by default. So let's pass here. And let's say, like, we don't have to do these in functions. It just feels cleaner. It feels like a cool way of doing it, like a kind of a clean way of doing it. So we'll test tuple pop with this. We'll test it with my tup. And we'll test it like this, and this should pop off the last element. So this should give us something that looks like this. And then let's also pop index 0, 1, 2. So that will give us 4, like that. We'll pop out 3. Okay, cool. So all we have to do for this is return tup. And I think we'll just say if IDX equals none. If IDX equals none, IDX equals tup sub. Oh, excuse me. IDX equals -1. Okay, and then we'll say tup sub. I don't even need to set IDX to anything right there. I can just return what I want to return directly, which would be a little easier. Let's just do tups sliced starting at the beginning all the way up to but not including -1. Okay, and that should give me my first one there. Okay, so 1, 2, 3. So that's working without that second argument. And then let's make it work for the second argument. So return tup up to but not including IDX. And then, oops, gosh, keep hitting page up and page down. Plus, and I think we just do this, and I believe that will exclude it. Nope. So start at the beginning, go up to but not including. Oh, this does include it, so we have to do one more. Cool. And just out of curiosity, if I make IDX equal -1, is that going to work? No, it does not work. Okay, we'll just leave it like that. So that'd be an example. This will emulate pop's behavior, right? So given no element, it'll just pop off the last one. Given no index, it'll pop off the element at the last index. Given an index, it'll pop off the element at that index. But because it's a tuple, oh, come on. Because it's a tuple, it'll never alter the tuple. Right, so none of these will change the value of the tuple. Remove. So remove is kind of like pop, but instead of its argument being an element, it'll remove an index. Or excuse me, the other way around. Instead of its argument being an index, it'll remove an element that you pass to it. So I think we would just do something like, let's do this. Let's just copy this. And I think remove has like a limit. I forget, it takes another argument, but I'm not going to try to recreate it perfectly here. We'll just do something quick. So let's call this tuple remove. And we want to remove 2, so that'll give us 3 there. And this one we want to remove oops, I don't need this second one like this. This one, let's see here. I'm trying to think. What's a good... Let's do that. Okay, so we'll have that 3, 2, 4. So this is actually what we expect for this first call, and I think just one test is going to be fine for this. Okay. So it's going to remove the first occurrence, and I think I'm going to be just real lazy here. I'm going to say for L in tuple, if L equals LM, return tup sliced at, let's enumerate, IDX, and we want to start at the beginning, go up to, not including IDX, and add it to tup sub IDX plus 1, and then go to the end. Okay. Okay, so 1, and then we removed that first 2, and then 3, 2, 4. So this is essentially a remove method. Reverse this one, tup sub colon colon -1. That's a reverse. That's how you do it. Oops. We'll do my tup. There we go. So that'll reverse the tup. Again, it's not a mutable operation. Does not alter the value of the tuple. It just gives you the backwards version. And then sort, we have to cheat a little bit. This is the one mutable method that we don't really have an analogy for unless we just write our own sorting algorithm. Fortunately, Python has one built in. Sorted. Do notice, though, that this actually gives us a list back. So if we want it to be a tuple, we have to explicitly cast it as a tuple like that. But this will give us a sorted version of the tuple. So yeah, that's how we can emulate the mutable behaviors of lists with the immutable tuple. Oh no. Let me just check on Slack. I'm hoping Slack is holding steady here. Ah, oh no. My Slack is like not updating. Apologies. Let me try to do this again. Okay, so I think you returned the remove behavior for pop because you returned the whole tuple. Let's see. Let's see. I returned the whole tuple. So for this one, the difference, so really the difference between pop and remove is the argument. With pop, you pass in an index, and it removes the, or it pops the element at that index, and it also returns that element. You know, I suppose I'm not actually doing that because I would need to. Yeah, that's a good point. Because pop not only alters the list that it's called on when it's a list method, but it returns the value that it popped off. So let's actually recreate that. We'll actually return a tuple for this. Well, I mean, we were returning a tuple before, but we'll return a tuple containing the element followed by the new tuple with that element removed. So we'll say tup sub IDX, and then this will just be sub -1. That was actually the wrong behavior. But in either of these cases, notice I have my tup equals 1, 2, 3, 4. In either of these cases, I'm not returning the whole tup as I passed it in. So yeah. And then with remove, this is let's see. Sorry. With remove, this is going to, yeah, this will take in an element that is a member of tuple, and if it's in there, it will remove the first occurrence. I have this return right here just to stop the looping so it doesn't remove all of them. I might could do, so let's just see, let's see like this. Lem equals -1 equals this, and we'll say lem minus equals 1. And I think remove has an argument like this, so if lem equals 0, break, and then we'll return tup, right? So that would actually give me that limit behavior that remove has. I think remove has that. Whatever. So yeah, so this will take in an element and remove all occurrences, or remove the first occurrence by default, which means actually I want to make this, by default I want to make this 1. Yeah, that way I decrement, remove, and then break if lem is 0 after 1. Okay. Alright, so anyways. Cool. Yeah. And then I hope that answered your question about whether pop returns the element that was popped as well. Obviously I have to do this a little bit differently because pop is a mutable method, right? It has two effects. One is that it returns the element, and two is that it removes the element from at the index that you popped from. So when I'm writing a function like this, like tuple pop, I have to return a tuple that has the element followed by the altered tuple. But anyways, I mean, hopefully it's clear. Like, I think about pop as removal by index. I think about remove as removal by element. You know, this isn't so much about like how do I build a perfect analog for a pop function or a remove function for tuples. It's more about like I can use slicing, concatenation, slicing, and indexing to do essentially all the tasks that I could do with mutable list methods. Some of those, like exactly the ways that you have to go about those things, are going to be different in certain circumstances, but you will be able to recreate in the end. You'll be able to recreate the same effects, even if the particular behaviors line by line differ slightly. But yeah, concatenation, slicing, and indexing will get you through anything. So. All right, let's just do this up here. Cool. Awesome. Glad that was helpful. All right. I like it when I get to dive into something like that. That's always fun. Stuff never gets old. All right, declaring tuples. Well, I mean, we just went through like kind of everything about tuples. The next one's about tuple immutability, so I think we're a bit ahead of these. Declaring tuples. Suppose it's worth mentioning again. Tup, an empty tuple. Oops. Tup equals empty tuple, single element tuple. Let's just do 1. So a single element tuple requires a comment. It's the only kind of weird, unnatural feeling one. Multi-element just is what you think it is. if there's any elements in it at all, the parentheses are optional. They're not optional for an empty tuple because this is not valid syntax. Python's not going to be like, oh, well, I guess since there's nothing there, I'll just assume it's a tuple. You got to have the parentheses. So sometimes you will see this. I say for the sake of simplicity, just put parentheses around it if you mean for something to be a tuple. I see this happen a lot where people will try to avoid using excessive parentheses, and like ultimately, yeah, sure, that's fine. But like when you're just starting out, I think parentheses can make things look more complicated. But they tend to just if you just bite the bullet and just like err on the side of more parentheses than you need, you'll be okay. So, and same thing goes with tuples at this point. This looks nice and clean, but like don't bank on it as always being as Python in every circumstance understanding that without the parentheses as a tuple, you can get away with it for you can get away with this for declaring a tuple and returning a tuple. So if I have a function that returns a tuple, I can do a comma b. Sometimes you'll usually hear this referred to as like multiple returns in a function, which makes it sound like it's got multiple return lines or that it has some special feature about functions that we haven't explored yet. It's just a tuple, or it's just a function that returns a tuple, and like we just make ourselves feel fancy by saying Python supports multiple returns. It supports returning tuples, and it does so elegantly without needing parentheses around the tuples. So when you hear somebody talking about multiple returns in a function, or a function having multiple returns, it's just a function that returns a tuple, and it just looks like that, right? So that's, presuming that A and B in this case actually had values, that would be a syntax error in that particular case. But yeah, so that's declaring a tuple. You will see it without the parentheses. I suggest for the sake of ease and consistency, just use the parentheses all the time. So we don't need to do that. Declaring tuples. So let's just try this out. Which of the following is a valid tuple? This one. This is not a valid tuple. This is going to evaluate as a string. Let's actually look at that. Let's say tup equals parentheses t print type tup. That's a lot of t's. So that's a string, right? So that did not evaluate to a tuple, and that's because it doesn't have a comma. It's a single element tuple without a comma. See, there's my string. If I do my comma, then Python recognizes it as a single element tuple. Am I crazy here? This both look like valid tuples. I'm gonna go for this one. Can tuples not hold lists? Tuples can hold lists. Am I wrong about this? Tuples can hold lists. Yeah, that's a valid tuple. I think what they're saying is, like, to me, I'm like, yeah, this is a, oh, of course it's not. Of course it's not. Oh, I totally swung at the curveball. Dang it. Oh, it doesn't have a comma at the end. It does not have a comma at the end. That's a list. All right. I got. Fair and square. Here I am talking about single element tuples. I won't shut up about them. Well, I'll get you. It's one of those weird things that I mean, Python syntax is usually like very elegant and very nice, but that's one kind of little rough spot in Python. Not too bad, but just kind of a little thing. Single element tuples end in a comma. Okay. Let's do this one. So inside a variable called myFirstTuple, create a tuple containing 4 items according to the following specification. First item should be the length of the list. Let's see, did I like alter this at some point? Nope, that's the regular input. Okay. So my first tuple equals a tuple, which is the len of list. The second should be the maximum. Oh, excuse me. Should be the. Oh wait. Oh, that is the maximum of the list. Max list, and then the minimum. Min list, and then the average, which is going to be sum of list over len list. Let's do that. Oh, no, it's not necessary. Cool. Write a function called Tuple info. It takes 2 arguments. The first is called list. Hold a list of values. The second is called find. Is a value to find. This function should return a tuple containing the value that was supposed to be found. The value that was supposed to be found, the number of times it was found, a list containing the indices in which it was found. The values should be returned in the tuple in that order. Okay, so the target, the frequency, and the indices. Okay. Indexes. Okay, so IDXs is a list, and frequency, this is easy. This is just list dot count find. That'll be easy. And then indices will be, or indexes will be 4i, 4i l in enumerate list. If l equals find, indices dot append I think that'll do it. I'm not even going to test it. You should test it though when you're actually writing your own code. I'm just leaning into the hypocrisy right now. Okay, there we go. I've also solved this problem like a dozen times in the past couple months, so yeah, I've been testing it. Cool. Tuples are immutable. Did you know that? Did you know tuples are immutable? I'm not sure if I mentioned the part about immutability. No, I'm not going to go over it again. I'll spare you. Let's do these challenges really quick. I'm sure this, as much depth as I went into, is probably as much as this goes into, but you can skim through this lesson and see if there's anything that I missed. It's possible. What will be printed to the console when the following code block executes? So we have our tuple, and I'm on guard. This is a single element tuple. Can't fool me a second time. It's got the comma there. Tuple example tuple sub 0, which is a list, dot append d, that's valid, print tuple, so that's going to be this. So this is going, since tuple sub 0 is a list, we can append to that list, and tuples don't actually hold the values that are within them. They hold pointers to those values. So tuple sub 0 is a pointer to the list. It's like a variable name. It's a pointer in the same way that a variable name is a pointer to that, right? So it points at that list, but that list actually lives elsewhere. It doesn't live in that contiguous block of memory where the tuple is. So the list within the tuple is a list, and it is mutable just like any other list. It doesn't inherit the immutability of the tuple that it's inside of, because it's not inside of it. It's just referenced to by the tuple. So that'll be that one. It won't be, and here I'll just cover these other ones. It won't be this one because we appended to that list. It won't be the first one. It won't be an attribution error because we're appending to the top sub 0, that first element, which is a list. We can append to that. And it won't be this because this lacks the comma at the end. So this is not valid code, even though that got me last time. All right. This one also has okay. All right. Complete the function takes a tuple called tup and an int called x. The function should return a tuple where x is in the tuple at index 2. Okay. You can assume that the contuple. You can assume the tuple will contain at least 3 elements. Return a tuple where x is inserted in the original tuple. So I'm going to assume that emulates our insert behavior for lists. And let's just, we'll reference that. This is a nice thing. Writing your own code, you can just reference it. Tuple insert. So that's basically this. So this returns the tuple. Okay, so I think it's just, if we just return tuple insert with tup, and then it takes the IDX, which we want to be 2, and then it'll take x, which is the integer. So I think if we just submit this, let's try that. What? Oh, okay. Just took a second there. Correct. Yay. There's another example of it, you know, just baked in, but I write code twice, eh? All right. Cool. I think I'm going to wrap it up here. We'll just start with this question for next time. Yeah, this is our normal stopping point. So yeah, hopefully everybody enjoyed it today. Always like when I get to talk about tuples and immutability, because I think they're important concepts, particularly mutability versus immutability. That was one of those things, like when I realized it, it was sort of a pretty major breakthrough in understanding computing and computer science and programming in general. So not the biggest, but definitely one of the big ones. So yeah, it's definitely something that's worth going over. Cool. Yeah, I'm glad it was helpful. You're welcome. Yeah, go ahead and leave a like, comment on the video if you feel like it. And I'll see you all next study hall, which will be on Monday. Yeah, feel free to DM me in the meantime. I'll get back to you as soon as possible. And y'all have a great rest of your day.